Usually, since STEM is science, technology, engineering, and maths, and we usually have 4 to 5 people in our group. Usually, one of them is generally good at one sort of topic. So one would be good at engineering, and one other person would be good at maths. So when it comes to iSTEM, they generally try to integrate different topics together, like with the boat, maths and science, to see how the boat can float.
Like in the mathematics concept, you'd have one person who's quite good, who'd know how, for example in our boat project, how Bernoulli's principle works. And then when we go back into the classroom to designing our boat hull, you'd have one person who's better at that designing concept.
So the STEM project has helped us in our other courses by giving us a head start on some of the subjects. So for example, we started learning about the 3 laws of motion developed by Isaac Newton, and we later learned more about it in our science course from last term.
Also within our STEM projects, we got the chance to work in groups, and from this we learned that it was vital to plan ahead with lots of organisation, including group contracts and timeframes. And from this, it really helped us to do this in other projects as well, so we don't get delayed.
And I believe it will help us if we want to do subjects such as engineering later on in the future, because we've been learning how to build drones and 3D modelling and things like this, and I really think that this could help us, especially because we've gone through like the hardest parts of it, and we've used the problem solving process to learn how to use them.
So we take really complicated parts of engineering and science and break it down into small, simple lessons.
So some of the skills which we've taken away from iSTEM are making projects with prototyping and breaking down complex problems into easier problems for us to solve. We don't really get these from any other subjects, as we don't have much of a hands-on experience with our projects.
What we did with this complex problem is that we broke it down into easier parts and manageable parts. So one would be we had to break it up into learning about the boat design holes, which would give our boat a slight advantage. Also the science behind the boat holes, how to get how a planing hole gets onto the rise of the wave, so it has less resistance to the water. So things like that help us take away from the program.
We started learning about how to make a drone. So the aim of our drone was to be as efficient as possible and save human life.
Before we work on our sketches, we had to know the science concepts, so we need to know the 4 aspects: drag, thrust, lift and gravity.
And so this also helped us in our science class, because we got a head start on everything else. So we got, where we did this in term 2, we started working on gravity and thrust in term 3, so the different forces. So then after we had learnt about these different skills, we started developing. So we started designing in teams of about 5, was it? Yeah. Yep. So it was 5. We started learning and developing our drone.
Term 3 saw the students of Year 9 complete an iSTEM project about boat function and boat design. This project was based off the UNSW Boat Challenge, which was launched just at the beginning of Term 3. The project began with a boat expert coming into the classroom of the Year 9 iSTEM elective class and introducing boat design and boat function using an extensive amount of jargon that at first was quite overwhelming, but as we progressed through the project we became more understanding of the terminology he used. The purpose of this event was to, of course, introduce students to boat design and function, and to get students prepared for the project that was given.
So our task that we actually had to do was to create a boat that could carry a can and can race 10 meters. So the expert, he kind of gave us an introduction to the project and what we can expect in this project and how we can apply some of the terminology he used to our work. So what we first started doing in the project was researching. So we first decided to learn about the different holes, so displacement holes and planing holes. We decided which is better, which is planing hole for racing, and from that we can apply that to our design.
For example, with our project last time with the drone, we're in groups of 5, and it was a pretty complicated project. As you would think, we're making a drone from scratch. Well, in order for the project to work, you need to collaborate and talk to each other, because if you don't, you're not going to agree on things and the project will start to fall apart. Like with the laser cutting, if someone might not listen to the other person and you don't talk about it, they might go over and do it all wrong. That'll just take up time.
So communication is vital in STEM because there is a lot to do. So unlike other subjects, so STEM incorporates 4 subjects: science, technology, engineering and mathematics. So with that being said, you really do have to communicate with your group members. So like Corey said, with the drone project, we did have to communicate more so than other projects because we did have to take measurements so we could laser cut them on the laser printer. So some groups had trouble because they didn't communicate as well. So when they didn't communicate, their measurements were off, so their drone was wouldn't be able to fly. So if you do communicate and collaborate well together, your drone will work and it will succeed.